Welcome everyone. Today we have this quite short and simple problem, but we will discuss it in detail. I have seen some videos on YouTube explaining this problem, but I find a need to explain it deeply. So the problem is a plus bc is 2021 and ab plus c is 2020. Find the integral solutions of abc. Means what? A, B and C should belong to integers. Okay. Now since right away go and subtract these two equations, a plus bc minus ab and minus c, and here you will get 1. So now you are getting a minus ab, club them, and bc minus c, club them, and then take some measures to find out the factors. Okay, factorize it in short. So if we take a from a and b, ab will get 1 minus b, and then if we take c from bc and c, we get plus c, and we get b minus 1 is equal to 1. Or a 1 minus b minus c 1 minus b, we can flip the numbers inside the bracket and change the sign of the bracket, is equal to 1. So now you have 1 minus b and you have a minus c is equal to 1. So now we are talking about this equation in short, and this equation has two brackets in which three variables are there, a, b and c. All three variables are integers. We have to find integral solutions, so we will talk about integers only. So we say that abc are integers, and we know that addition and subtraction, under addition and subtraction integers are closed. Means what? This is actually the closure property. Of integers. In integers, in hold, under addition and subtraction. So we will keep this thing in mind, that if we add two integers and if we subtract two integers, we will get an integer only. So in other words, we can say if we add two integers, we cannot get a fraction in a layman's language, or if we subtract two integers, we cannot get a fraction. Okay. So on one hand, on the left hand, you have two integers I1 and I2 getting multiplied, and on the other side you have two integers. Okay, and multiplication also, closure property holds for multiplication also. So on one hand side you have multiplication of two integers, so necessarily on the other side you also have multiplication of two integers. So there are three cases. Case 1, if we multiply two integers, we get 1. How do we get 1? Either we multiply 1 by 1. Case 2, if we have two integers I1 and I2 and we multiply them, we get 1 by multiplying minus 1 to minus 1. Case 3, we have two integers I1 multiplied by I2 and we get 1 if one integer is reciprocal of other integer. Means what? I1 is one integer and I2 is 1 by I1. So there are three cases. We will discuss one by one all three cases and see how we will get answer. In all three cases we are getting 1. Okay, so let's talk about case 1. When I1 and I2 are 1 and 1, so it means 1 minus b is equal to 1 and a minus c is also equal to 1. So this gives us b is equal to 0 and a minus c is equal to 1. So if we put these values in any of the equation, we get that see, one of the equations is what? A plus bc is equal to 2021. Take a plus bc is equal to 2021 and b is 0, so a is equal to 2021. If a is 2021, then a minus c is 1, so we get c is equal to 2020. So one set of solution from case A is a is equal to 2021, b is equal to 0 and c is equal to 2020, and all three numbers are integers, so it's a valid solution. Now let's talk about case 2. We have 1 minus b equal to minus 1 and a minus c also equal to minus 1. From here you get b is equal to 2, and if you put b is equal to 2 in one of the equations, you get a plus 2c is equal to 2021, which is not enough, and we have here a minus c is equal to minus 1. So we can write a minus c is equal to minus 1, and we subtract these equations, minus plus plus, this will cancel. So 3c is equal to 2022, c is equal to 2022 upon 3. So you have 6, 18, 2, 22, so 21 is 7 times and 1 is 12, 12 is 4 times. So you are getting 674, the value of c. So from case 2 you are getting a is equal to what? I haven't calculated a yet. So let's calculate a also. A minus c is equal to minus 1. So a minus 674 is equal to minus 1. So a is actually 674 minus 1, which is 673. So a is 673, b is 2 and c is 674. All three are integers, belongs to z, so it's a valid solution. Okay, so we got two valid solutions. Now let's talk about third case, case 3. And case 3 is I1 into I2 will always give you 1 in case when I1 is a reciprocal of I2. Okay, so it means that if 1 minus b is multiplied by a minus c equal to 1, in this equation this is I1, this is I2, so one of the quantities has to be reciprocal of the other quantity, means 1 minus b should be 1 over a minus c, or you can say a minus c is 1 minus b. Okay, so but a minus c and 1 minus b both are integers. Okay, so let us take one integer as let us take a minus c as one integer, which is 3, any number of your choice, 3. Then 1 minus b will be 1 by 3, and this will give you b is equal to 2 by 3, which does not belong to integer. Now this will happen every time you will reciprocal an integer. You will get, see, the thing is, the conjecture is, if an integer is reciprocal then it becomes fraction. Okay, so I'm saying fraction, and you can say rational number also. So why this happens? There is only one case in which this thing does not happen, and that case is if you take an integer I is equal to 1. If you reciprocal that integer 1 by I, then also you get 1. So this is an exception, but we have already talked about this exception here. In case 1, we have taken the integer I1 and I2 as 1. So we need to find out more solutions of I1 and I2 other than 1. So for I to be an integer greater than or less than 1, and I is not equal to 1, we don't get any such solution in which I1 and I2 are both belongs to Z, when I1 is reciprocal of I2. So in third case we won't get any answer. In first and second case we are getting answers. So the final solution is case 1, from which you get A, B and C. Case 1, the solution is A, B, C is 2021, 0 and 2020. Case 2, in which B is 2, C is 674 and A was 673. So these are the only integral solutions that you will get from these two equations. Thanks for watching the video, and if you want to comment on my solution, you are most welcome in the comment box. Let me know other solutions, other approach also. Thanks for watching the video.